Right, hello. Just going to do a quick audio test. So I think on the last video, my voice sounded a little bit off to me. It's like some extra gain on the mic. So let's just double check that's not coming through and that the mic's all set up fine. Just give me 2 seconds. See how it sounds. I think that's better. Yeah, that sounds good. Okay, right. Plan for today. Let me just pop this away. That can close. Right, what we're gonna do is we are looking at Brackeys GDScript tutorial. So last stream we went through the other Godot tutorial that Brackeys did a few months ago, and hopefully this looks like it's coming through into the next part of a series. Although I don't know if there's going to be any more. I think it might just be these two videos for the moment. It's part of the Brackeys tutorials. But where did we end up? We had this little tutorial game, which we're going to open up and have a look at. Let's just move a few little windows around while this opens. That looks better. We're going to put on our... Oh, that text is way too long. Let's just move that across. So we can see that. Is that better? Yep. Actually, that can come down. Something like that. That's better. Okay, cool. Right, so the game that we put together with the Brackeys tutorial last time was this little platformer that gave an overview of how Godot works. There's not really much to it, but we didn't follow the full tutorial. We just got the gist of most of it, but it gave us a good idea. So I believe that this next tutorial might be a new project. Let's just have a quick look. Yeah, it's labels, all that kind of stuff. Yeah, it doesn't look like it's the same project. Cool. Okay, so let's close this down and open up a new project. Hey Zimni, how's it going? Welcome in. How's your week going so far? All good, yeah, thank you. Project-wise, I've not really done any more. We're just going to follow along with this Godot GDScript tutorial today. Get a better understanding of that, and then we'll probably either do some... oh, actually, the play rating is over, I think, for the GMTK Jam. I think that's done. But we might just play some games from that jam. Have a look at some of the top ones. You need to write something to work and it's pure pain. Oh no. You're procrastinating away from it, right?
GDScript.
Right, so if I pause my music, how loud is this? Is this loud enough?
A high-level, object-oriented, imperative and gradual...
I think we can go a little bit higher on that. And what we're going to do, we're going to put this in a separate research screen, which is how to program in Godot. There we go. So if we put this off to this screen instead, does that look okay? Can go a little bit bigger by the looks of it. Let's see. I think that's all right. Maybe a little touch bigger. Is it some like documentation then you need to write? Or a bit of code? That's where you're avoiding it. Right, then we get that screen there, that screen there. I think we'll probably be doing a new project, but I'll wait until the point in the tutorial when we need that. So let's see how we go.
Programming language with syntax a lot like Python, built specifically for Godot. I know that sounds like a lot, but today we're going to learn it. While it's of course impossible to cover everything an entire programming language has to offer in just one video, we'll certainly try. In fact, we'll cover everything from variables and conditionals to getting input, inheritance, dictionaries,
methodology for 2 new projects. Wow. Yeah, that doesn't sound especially fun. Yeah, I can understand. Oh. Trying to get it so I can actually see
signals and
OBS behind the screen as well.
Perhaps we'll even figure out what GD stands for. Gandalf script? Green Day script? Gadolinium? We might never know. We'll start with the things that are considered to be most important for beginners and then move on to more abstract programming concepts as we progress. It's not
yeah.
as long as it is an overview.
Next
lean back,
next Sunday, isn't it? It starts. So hopefully I can get ready and have like a default project ready for that. How long does it last? It's like it's a 7-day one, isn't it? It is. I've got it in my calendar from the 8th of September to the 15th. 1 week. Nice. Well, I have to see how that goes.
Know that you don't have to understand everything the first time. Also, it's totally okay to stop the video and try some of these things out. You can always come back to it at a later time. We've made sure to split everything into clearly named sections, so hopefully you'll be able to use this as a reference manual going forward. And if you're a seasoned programmer transitioning to GDScript, this video should provide you with a nice overview of the tools at your disposal and how to approach doing different things. Keep in mind that this is a video on GDScript, not an introduction to Godot. So if you've never opened up Godot before, I suggest you begin with our video on making your very first game in Godot. Alright, without further ado, let's learn GDScript.
Well, hopefully a lot of this is going to be pretty base level.
To take your skills to a whole new level, Codecrafters is the
programming,
Codecrafters allows you to practice
so we won't have to
by challenging yourself with
follow along too closely.
Build your own Git implementation, your own HTTP server, or even your own BitTorrent client. Along the way, you will practice advanced system design and gain a greater understanding of lower-level programming concepts such as networking, OS interactions, and performance. And when you're done, you'll have a really impressive project to add to your portfolio. On top of this, you get to try new
let me just get rid of that.
C++.
Why are there so many bots? Boo. Yeah, boo bot. Ban. There we go.
And many, many more. Also, new challenges are constantly being added. I, for one, voted for the compiler challenge to be next. So become a better software engineer today by signing up for Codecrafters. Use the link below to get 1 week free and 40% off on all membership plans. Hello world. So here we are in an empty Godot project. It's really spacious in here. As it is custom, let's begin by
Godot.
some code to print a message. To do that, we need a test scene, so let's go and hit B+.
Wolf main Matt. How's it going? We're going to create a new project. So we're just going to call this Brackeys GDScript. Cool. Thanks for the lurk, and good luck with the methodologies. Hope they go well. We don't want this here. We want this back in. Where's my desktop? It's going to be desktop, Godot projects, select current folder, Brackeys GDScripts. You need it. I'm sure you'll manage. So. Cool. Create and edit. And then when we've got this open, can I do this a higher quality? Yes. Be a bit easier to read the text.
I'll add in a node, rename it to main, and let's save this as a scene. So I'll hit Control S, hit save. Let's add a script by pressing the scroll. We'll use the default template, and the name of the script should be main.
Okay, so we're just going to add a default node, right? So this basically all going to be scripts-based program, I think. I don't know if there's going to be much in terms of any other parts of Godot. All good there, thank you. How are you doing, Wolfbane?
As well with a non-capital M. This creates a script with 2 functions. We'll start by focusing on the top one named ready. Think of this as the start of our game.
Right, if we're going to follow along, we're going to have to do this at normal speed.
And let's save this as a scene. So I'll hit Control S, hit save. Let's add a script by pressing the scroll. We'll use the default template, and the name of the script should be main as well with a non-capital M. This creates a script with 2 functions. We'll start by focusing on the top one named ready. Think of this as the start of our game. As it says here, this function is called when the node enters the scene tree for the first time, which happens right when we play our game. So we can put code in here that we want to happen.
What's the game concept? Okay. Well, I started using Godot briefly. Let me just pop some music on. Just there was a game jam 2 weeks ago, which is GMTK, and the idea was going to be around what was the theme was built to scale, and the idea started with like some kind of lab environment where you had a machine that would scale items up and down, and you'd have to like combine them and figure out ways forward and that kind of stuff. But I kind of didn't get enough time to finish the game, so rather than doing too much further development, I thought I'd actually go and learn how to use a bit more of Godot before going back to that. So what I'm thinking of doing is I'm following this these 2 Brackeys tutorials, and then I'll either continue on with that idea or we'll start prepping for the Brackeys Game Jam, which is coming up next week. It's like a week on Sunday. So having like a base level like game file that I can start from. Thanks. Do you do game development? Seems like if you're interested in Godot, you must must be at least adjacent to it. Alright, let's get this back up and running.
Get rid of the other function for now. You can zoom in by holding down Control while scrolling. Now, right now, the only thing in our ready function is the pass keyword. Pass basically means do nothing, and it will appear in functions we haven't filled out yet. So let's replace it with some code that prints our message. We'll write print, and inside of the parentheses, we'll put our message in quotation marks. Hello.
Hello world.
We can then run the game by pressing this button here or hitting F5. It's going to ask us which scene we are going to run.
Ooh, developing a sports game. That sounds cool. Are you doing it as like a indie project, or is that part of your work? Hobby, or like full-time, just going for it?
Current. And while our game isn't very exciting yet, we can now see that the console prints our message. The output window here, or the console, is where it will display prints, and is also where we check for errors. Now, to stop our game from running, we press the stop button here or press F8. Syntax. Now, this might have worked for you and it might not. That's because there are a few things to be aware of when writing GDScript. The first is that statements like print here terminate with a new line. There's no need to add a semicolon at the end like in many C-based languages. And GDScript, similar to a language like Python, uses indentation to determine the structure of your code. This means that you use tabs to tell GDScript where your code belongs. In our example here, I'm using a tab to tell Godot that our print line belongs to the ready function. If I delete this tab, I get an error. Also, GDScript is case sensitive. So if I write print with a capital P, I will also get an error. So just a couple of things to look out for there.
Pretty
Now, printing
standard.
to the console is cool. Or I mean, maybe not as cool as backflips, but well, I can't teach you to do those. But I can teach you how to display text in the game window instead. To do that,
oh, Horizon Worlds, nice.
Node through script. Modifying nodes 1.0. First, we need a node to modify.
Cool. Well, I hope the game development's going well.
Node, choose label. I'll zoom in.
Is it a real sport that you're making it on, or is that are you making up your own sport and own rules? Hi, Emmanuel. How's it going? Welcome in. Okay, we're adding a label.
Let's add a default text. This is a label. I'll
wait.
it
Can't do that.
Override the font size. Now,
Let's go back to here to do this. Yeah. Control A label. And we're doing something on font size, did he say? Font size, label, text.
And let's add a default. Center it on the screen. Make some more room. Let's add a default text. This is a label. I'll center.
Ooh, that sounds cool. Center it on the screen. How do we... He just moved it, didn't he?
Use label. I'll zoom in. Center it on the screen.
Oh, wait. There's a button for it. Alignment here. Okay. That's cool.
Make some more room.
It's going to make it a lot easier.
Text. This is a label. I'll center it. And...
Where's our text field? Here we go. This is a label. Oh. Center. And center.
Override the font size. Now,
font size is down here somewhere. Theme? Was it theme? Theme overrides. Font size is here. We're going way up. Cool. I love Godot's format because it's just visual folders. It does, from my limited use of it so far compared to... So I did a few game jams before in Unity. And like a few little game projects, but nothing that's like... They're all kind of just learning how it works. But so far using at least Godot 4, or this is 4.3, it seems to make more sense to me than a lot of the figuring out where in submenus and stuff like that in Unity things are.
to edit the text of this label through script, we need two things. We need a reference to the label, and we need to access the property in the label that we want to change. In this case, the text. If we hover over text, we can see the name of the property through script, which is text with a non-capital T. So in our main script,
that's useful.
A reference, and we can actually do this by simply taking the label and...
So you can actually find out very easily what the property's called. That's so much easier.
dragging it into our ready function. Then we can access the property by going dot, and we'll type in text and set it equal to hello world. And now when we
unselected,
our label changes to hello world. And we can use this exact method to change other things as well, such as the color of the text. In fact, there is a property called modulate, which allows us to tint sprites and UI elements.
We save
in
this.
The inspector, you can...
Right, let's pause that. We'll, didn't mean that. And to run this game. So then It will change automatically to hello world, hopefully, when it opens up. Nice. Okay. Nice and simple. It's all going to be simple stuff to start with.
Taking the label and our label
So skip forward a little bit.
Sprites and UI elements. In the inspector, you can find it all the way down here under visibility. Let's change it to green. So again, we'll click and drag to create a reference to the label, write .modulate, and set it equal to color dot. Here we have a bunch of different colors. We'll choose green. And voila, our label is now green. So this is how we can make changes to nodes when our game is running. But right now, not much is happening during our game. So let's see how we can use input.
What was the modulate equals
to color dot
green. Okay, nice and easy. Oh, it's all uppercase. Okay. Does it automatically save? Yeah, cool.
Bunch of different colors. We'll choose green. And voila, our label is now green. So this is how we can make changes to nodes when our game is running. But right now, not much is happening during our game. So let's see how we can use input to make our game respond to our actions. Input. Let's say we want to turn this label red when we press the spacebar. To do this, we first need to set up an input action. We'll go Project, Project Settings, Input Map. Here we can add actions. Actions allow us to bind keys to something that we want to happen. Common actions would be shoot, jump, or...
Arrange everything in your game composition. Just make your elements as you go, and then give you options to tether the connections via signals or assigning nodes. Yeah, it's that whole like... It's basically all a lot of composition kind of stuff, isn't it? So you build up your separate scenes that can be as small as you want, and then just plug and play pretty much.
So on. In our case, we wanted to
seems so great.
Color. I'll just go ahead and call it my action, so we can use it later for other things. Now let's hit add, and here's our action. Let's bind a key to it by pressing plus. It's now listening for input. I'm going to press the space bar and hit OK. And now our spacebar is bound to my action. Then in our script, we need to create an input function. We'll write func for function underscore input, and let's hit enter to autocomplete. Now just like ready, this is one of the built-in functions of Godot. But instead of being called at the start of the game, it runs every time the game receives any input, such as when we press a button. Event is what we call the information about what triggered the function. Was it a movement of the mouse or the press of a key? We need to check if the event that triggered the input was our action being pressed. So we'll write if event.isActionPressed, and as you can see, our action shows up here. My action.
Is action pressed.
We'll put in a colon.
My action.
And if we pressed my action, well, then we'll change the color. So we'll drag in the label, write .modulate.
Can I just type it out?
And set it equal to color.red. And we can just as easily check if the action was released.
Or do I have to drag in?
Event.isActionReleased this time, my action. Well, then we'll take the exact same line and change it back to green. So now when we play and I press the spacebar, it turns red. And when I release it, it turns back to green. That's right, we made a party. A disco party.
Right. And then we want to do this again. Let's see, because if I've just typed it in, I think it should be fine, because it should just be the label. The only thing you don't like is you can't joint map buttons directly from the input menu. Okay, so you mean in this input map here, you can't have an action that would be like, I can't combine here two separate inputs to say, okay, this only happens when I'm holding like two button prompts and stuff like that. But that's not too bad. I think that'll be all right. Doing via script, yeah. Okay, nice. Nice and easy. All right, what's next?
Now this is just one out of many ways to handle input in Godot, but since we're focusing on the GDScript language, I'm not going to go further into it here. I'll make sure to provide a link to where you can learn more about input if you're interested. Variables 1.0. Variables are essentially containers that hold information. In the case of a player character, we could use variables for information like the player's name, health, damage, and perhaps if the player is alive or not. Let's make a health variable. At the top here, I'll write var for variable, the name of our variable, and then we'll set it equal to a default value. Now we can print this variable inside of our...
I'm so used to putting semicolons at the end of lines. It's going to take me a little while to get used to.
See that it now prints 100. Now we can easily change our variable.
Okay.
So before printing, let's assign a new number. Health equals 40. We can also assign a calculation. So health equals 20 plus 30. We'll set our health to 50. We can also add health plus equals, and then 20 will add 20 to our health. And subtract health minus
I'm not
equals.
too fussed about following along with all this bit.
We do times equals, and to divide we do slash equals. So if we run this now, it will do all of these calculations from top to bottom and then print out the result.
50, 70,
which turns out to
60.
be 120. Let's
Yeah.
look at an example where our player takes some damage and we want to subtract the damage from our health. Let's try decreasing our health variable whenever we press the action we made earlier. So in the input function, we'll check if the action was pressed. And then we'll subtract
Health minus
from our
equals
health, and we
20.
can print the result. So now every time I press the spacebar bound to my action, we can see that I reduce the health. Really cool. But as you can see, we can currently reduce our health below 0, and nothing happens when we do so. If we were making a game, we'd probably want our player to die and the game to restart. Luckily, we can make our game react to variables by using if statements. If statements, or conditionals. If statements are the glue that holds all of our logic together. We've actually already used if statements to check if our action was pressed, but they can do so much more. Yet they are really simple. An if statement is just a condition that needs to be met in order for the code inside to be run. Let's
feel like
add
it's
an
gonna be
if
something like
statement
this.
here to check if our health reaches 0. So I'll make some room, write if health is less than or equal to 0. Well, then we'll set our health to 0, and we'll print that we died. And now when our health gets to 0, it prints you died. Now here we're using less than and equal to compare our health to the value 0. But there are many more comparisons we can make. Here are all the comparisons we use, such as is equal to, is not equal to, and so on. We can
Pretty
also
standard
add more
again with that kind of
conditions to
stuff.
one if statement. We use the AND keyword to add another condition where both need to be met, and the OR keyword to add a condition where only one of them needs to be met. Now, one really useful thing about if statements is that we can not only define what happens when the condition is true, we can also choose what happens when it's false. We do this using the else keyword. Let's add an else to print that we are still alive if our health hasn't reached 0 yet. So if our health is less than or equal to 0, we died.
So else print.
You are healthy. And even cooler, we can chain together if statements using else if or elif for short. So we check if our health reaches 0, and if not, else if elif our health goes below 50, well then we'll print that we are injured. And if neither of these two are true, we'll go to else and say that we are healthy. And if we play, we can see that at 80 we are healthy, at 60 we are still healthy, then we are injured, and at 0 we die. Very cool. Note that the if statement we made here is nested under another if statement. You can easily layer if statements to get more and more specific functionality. However, try not to overdo it. You can quickly get lost in the ifs. Actually, a lot of people don't know this, but that's why programmers and philosophers have so much in common. We both tend to spend a lot of time with the ifs and the what ifs. So if you get frustrated along the way, remember that so was Plato. Anyway, that's it for if statements. Comments. We use comments to help explain and remember the what.
Okay, so comments I think was quite easy. I think it's just the hash
can be done above or
symbol.
after a line. So if we have some code, we can make a
And
comment
also
above
we
the
can do
line.
control slash to add and
And this is
remove.
a comment about the code that follows, or we could make one right after. And this is a comment about this line only. We can also use comments to temporarily remove parts of our code from being executed. Here we simply put a hashtag in front of the code. And it's good practice to omit the space here to indicate that what follows is code. We can also select multiple lines of code, right-click and toggle comment. Just remember that you can't have a completely empty function. We need to add the pass keyword to avoid an error. Variables 2.0. When creating or declaring a variable, we need to think about where we do so. If we declare a variable inside of an if statement, for example, we can only use that variable inside of the if statement. This is called scope and is something that beginners often make mistakes with. If we want to use a variable in many different places in our script, we make sure to put it at the top, outside of any functions. So this is a script-wide variable. This can be accessed anywhere in your script. If you were to declare it inside of a function, you would only be able to use it in that function. So this is a variable we can only use in ready. Now, a really cool thing about variables in GDScript is that you can declare them without thinking about what type of data is inside them. Here's a variable that is either true or false, and here's a variable that stores a number. As you can see, they're created in the exact same way. In fact, we can even change the type of data that they hold just by reassigning them. So we can actually set our coolness to...
I was about to say, does it assign the data type when it's assigned a value? But no, okay, it's a bit like...
We need to be aware of what type of data we're working with.
A bit like JavaScript in this way.
Some parts of our game will expect a specific type of data, and we will get an error if we try to use another type without converting. Now, in GDScript, we have the 4 classic data types: Boolean, or bool, for true and false; integer, or int, for whole numbers; float, for numbers with decimals; and string, for text. Converting from one type to another is called casting. For example, we can cast an integer into a string. So if we have a number that is equal to 42, and we have some text, which is a string, well, then we can add the number to this text, but we convert it into a string by writing str for string, and then the variable inside of the parentheses. And if we print this, it works fine. We can do a similar thing to, say, convert a float into an integer. So if we have a variable called pi that is equal to 3.14, then we can convert this into an integer by going int pi, and let's print this. And it prints 3, a whole number. Note, however, that this automatically truncates the number. It does not round. It simply gets rid of the decimals. So 3.9 also results in 3. Some other data structures that are really common in GDScript are vector 2 and 3. Vector 2 stores 2 floats, x and y, and vector 3 stores 3 floats, x, y, and z. These are most commonly used for positions, so I can create a variable called position with some coordinates. I can then modify one of the components, so position.x plus equals 2 adds 2 to the x component, and then we can print the whole thing. And this gives a vector 3 of 5 minus 10, 5. Now, by default, GDScript is what we call dynamically typed. This means that we don't define what type of data a variable can hold when we declare it, which we've been using so far. This makes it fast to create variables and flexible because we can reassign data of another type at will. However, it is also more prone to error and less performant than static typing. Luckily, GDScript allows us to statically type any variables we want. We can pick and choose totally based on preference. To statically
so it's a bit like TypeScript as well.
We simply add the type when declaring it. So here, if we have a damage variable, we can specify
that's quite useful
and then
to have it optional.
So now this variable will always stay an integer. We can even have Godot automatically determine the data type by simply writing colon equals and then the default value. This is called inferred typing, and the result is exactly the same. The type is
that's quite useful as well.
Godot simply recognizes that 15 is a whole number and sets the variable to a type of int. This also means that the variable cannot change to another type. If we try to set it to a string, we get an error. Now, adding export in front of a variable will allow us to set it using the inspector. The value that we set in the script will just be a default value. So if we save this and select our node, we can set a value in the inspector. If we print our damage, we can see that this updates in our game.
Nice.
And we can always press the circular arrow to revert back to the default. Now, sometimes you want to define a variable that cannot change. For this, we use constants. So I'll write const for constant. We'll call it gravity. As you can see, it's standard practice to name constants with capital letters. And we'll set it equal to -9.81. Now we can use this like any other variable, but we cannot change it. If we try to do that, it throws an error. And that's it for variables. Great job.
Pretty straightforward.
Functions are the bread and butter of programming. They allow you to bundle up your code in small reusable packages. So far, we've been using some of Godot's built-in functions like ready and input. Notice how these are prefixed with an underscore. This is to show that they are not activated or called by us, but by the engine itself. But we can actually make our own functions and use them to do really cool things. Common functions to making games are things like jump, die, shoot, and respawn. And making a function is actually really easy. Let's make a function for jumping. So we'll write func, then the name of our function, open and close parentheses, and a colon. Then in here we'll put all of our code for jumping. So we could add an upwards force, play a funny sound, and a jump animation. For now we'll just print jump. But nothing is currently triggering or calling our function. Let's call it whenever we press the action we made earlier. So func underscore input event, and if our action was pressed, then we call our jump function by writing jump followed by open and close parentheses. And now when I press space, it displays jump.
Cool.
And at this point, I encourage you to add the sound effect yourself. Boing, boing, boing. A lot of fun to be had here. Now this already makes our code more readable and reusable. But right now, our function is just a simple command. We call it and it does some things. However, we can actually use functions for much more than this. They can have inputs and outputs. Let me explain. I like to think of functions as machines. Take for example this coffee maker. Just like the name implies, it performs a function to make coffee. To do this, however, it needs some input, some water, a filter, and some ground coffee. With this,
Can skip forward a little bit
and then
with
spits
this.
out an output, delicious coffee. In code, we call the input we give our function parameters, and the output is called returns. So let's make a function that adds together two numbers, func, add, and then inside of our parentheses, we add the parameters. So number 1 we'll call num1, and the second number we'll call num2. Then inside our function, we can add these together and store them in a result variable. So we'll set that equal to num1 plus num2. And for now, let's just print the result. Then in ready, let's try calling this function. So we'll call add, we'll give it the first number, 3, and the second one, let's do 8. And let's actually call it again. So let's do a higher one. Let's add 245 with 111. And indeed, it prints 3 plus 8, which is 11, and 356, which is the result of our second calculation. So here we've created a function with two parameters, the numbers we want to add together. But the function
How do
actually
we
returns
return?
print,
That's
which
the
means we can
question.
actually access the result where we're calling the function up here in ready. To return the result, we replace print with return. So we'll do return result.
Oh,
and now up here
okay.
we can store the result variable, set it equal to add, and we'll
Really
print the
straightforward.
5, and we can print that, and the result is 8. And because we have access to it up here, we can do more things, like add more numbers to it. So we can set result equal to add, and pass in the result from before, and add 10, and then print it. And there you go, we now get 18, because 3 plus 5 plus 10 is 18. Really cool. And just like when declaring variables, we can also statically type parameters and return types to make it clear that the function is made to work with numbers. So after num1, we'll specify that this is an integer. We'll do the same thing with num2. And here we can set the return type using an arrow, and this is also an integer. So now this function will only work with numbers. 3, 4, 6, 8, 2, 1, 1.5. Random numbers. Getting random numbers is very easy. The function randf gives a random number between 0 and 1. It's great for assigning probabilities to your code. Say we're deciding what loot to give the player, and we want to make some loot more rare than other. Well, in this case, we could create a roll variable and set it equal to randf. Then we could check if the roll is less than or equal to 0.8, which means there's an 80% chance that we print you found a common item. And if not, well then there's a 20% chance that you found a rare item. And if we play this, most of the time it's going to display that we found a common item. But if we keep playing, eventually there's a 20% chance, so at some point we'll eventually find a rare item. That was crazy. We can also use randf range and rand I range to get a random float or integer between a minimum and maximum value. Say to assign a random height to a character. So var character height equals rand I range for a random integer between 140 and let's do 210. And we'll print that your character is, then we'll insert the height, remember to convert to a string, centimeters tall. And we'll roll a character, and apparently I am a giant. Basketball, here I come. Documentation. GDScript is actually pretty well documented, and one of the really cool things about it is that the documentation is linked with the editor. If we hold down Control and click on something we would like to know more about, such as the rand I range function, it opens up the documentation right here in the editor. This is a really quick and easy way to check if you're using a function correctly. It also works for classes, which we'll learn about later. Arrays. Sometimes
That's
you want a
very
variable to
useful.
hold more than one thing. In fact, sometimes you might want to store a whole list of elements. For this, we use arrays. Defining an array is very easy. Let's make one to hold items in an inventory. So we'll create a normal variable and set it equal to open and close square brackets. This creates an empty array. We can then add elements inside the square brackets.
This feels like it's just basic JavaScript
Notice how,
again.
unlike many other languages, GDScript has no problem mixing data types within
It's like
an
a
array.
cross
So if
between
you want to string
JavaScript
array
and
we can of course statically type it. So
Python.
we add the type. This is an array, and the elements inside it are going to be strings. So that's the syntax for that. And now we get an error because 3 is not a string, so we'll replace this with feather. And 6 is also not a string. We'll replace that with stolen heart. Now the way that we access elements in an array is by using an index. When you add an element to an array, it is automatically assigned a number based on its position in the array. In this case, the first element potion has an index of 0, feather has an index of 1, and the stolen harp has an index of 2. So to access and print the first element in our array, we write print items, and then we access the first element, which has an index of 0. And this spells out potion. Pretty cool. We can just as easily change elements. This changes the second element to smithy sock, and the third element to staff. And arrays also have functions for finding, removing, or adding new elements. So to remove at an index, we write remove add, and then the index 1, this removes the smithy sock. And to add a new element, we write dot append, and we'll append an overpowered sword to the end of the array. Now, arrays can quickly become long and difficult to manually go over. Luckily, we can use something called loops to help out. Loops. Loops allow us to repeat code a number of times with small variations. They are perfect for iterating through all the elements in an array. If, for example, we wanted to print out all the items in our array here, we can do that easily by using a for loop. So we write for, then the name of the item that we're currently looking at, we'll just name that item. In the array, so in items, we will print out the current item we're looking at. So print item. And as you can see, it prints potion, feather, and stolen heart. This is cool because we can have any number of items in our array. The code will work just fine. We can also add more functionality, say to only print items that are more than 6 letters long. If item.length, so the amount of characters in item is greater than, let's say 6, then we're going to print that item. And now it only prints feather and stolen heart because potion is exactly 6 letters. We can also create loops that run a certain amount of times. If we write for n in 8, it creates a for loop where the variable n starts at 0, then goes all the way to 7. So if we print n, we can see that it runs 8 times and n starts at 0.
That's quite cool.
We say that n is the current iteration of the loop. Another type of loop is the while loop. This repeats as long as a certain condition is met. Now I think most people who know me would say that I'm a glass half full kind of person. And to those who disagree, let me go ahead and prove it by using a while loop to fill up a glass halfway. So I'll create a glass variable and default it to 0.0. The glass is currently empty, no arguing about that. Then we'll create a while loop that continues while glass is less than 0.5, so we haven't filled it up halfway yet, in which case we will add a certain amount to our glass. We do a constant amount like this, or in real life when I try to pour something into a glass, I'm not that precise, so let's add a random number instead. So we'll add a random float between 0.01 and 0.2, and then we'll print out how much is in the glass at the current time. Then when the loop is done, we get to continue down here in our code, and we'll print that the glass is now half full. And if we run this, we can see that the glass slowly becomes more full with a random amount each time, and then it says that the glass is now half full. As you can also see, it overshoots a bit because we're adding a random amount each time and not climbing the value, just like when trying to hit exactly half a glass in real life. My wife says that I add too much milk when I make her coffee. I think I'll refer to this going forward. Now, we actually have to be really careful when using while loops, that we don't create an infinite loop. These can be tricky to avoid and can very easily crash our program. Say if I were to remove this line that adds a little bit to our glass every time, well then our glass would actually never become half full, and we would be stuck in this loop forever. Now, I don't think this will actually crash Godot. Indeed, it didn't, but we get a lot of overflow errors, and as you can see, our game is definitely not responding. Not good. Finally, in both for and while loops, we can use the break and continue keywords. Break, as the name suggests, breaks out of the loop and moves on to the code after, while continue immediately skips to the next iteration of the loop. So if we were to write if glass is greater than 0.2 and then break, we can see that our while loop ends way early because we exit out of the loop before we even get to print that the glass reached 0.2. Dictionaries. They sound really boring, but they're really cool. While arrays are great for storing lists of elements, it's sometimes confusing to access each element with an index. Sometimes it makes more sense to use a dictionary. Dictionaries hold what we call key value.
Dictionary should be quite simple as well.
Words in a language. The key in this instance is the word we're looking up, and the value is the definition. Dictionaries in GDScript work the exact same way.
I kind of assumed that this tutorial was going to be more like, let's make a system that we could use in a game, like a input control system or something like that, rather than actually I think a lot of this is just introducing you to the language, which is fair enough. It's useful to know, but maybe we're going to skip through a bit more of this.
Creating an empty dictionary is really easy. Pairs inside the curly brackets. Say for example that we have multiple players in our game, we can use a dictionary.
So it's a bit like an object.
Player, villain, with a level of 35, and finally a player with a username boss with a level of 100. If defining on one line becomes too much,
actually dictionaries can be quite useful, so it's
good practice to add a comment
worth having a quick look.
And let's name this dictionary players. Then to get the level of a player, we simply type in the username. Let's print the level of our villain. So print, and we'll write players, type in villain, and this should print 35. And you can just as easily assign a new value or add another entry. So we can reassign the villain here to say 50 and add a new entry called Dwayne, with a whopping level of 999. And just like with arrays, we can loop over a dictionary with a for loop. When we do this, we're actually looping over all the keys in our dictionary, so all the usernames. And for each username in players, we will go ahead and print out the username. I'll add a string to separate, and then the level. So here we access our player's dictionary and input the username we're currently looking on to get the value. And remember to convert this into a string, so str, to cast to a string. There you go, it prints our entire dictionary. Now, just like with arrays, you can have multiple data types of keys and values in the same dictionary. And even cooler, you can actually have arrays or dictionaries inside another dictionary. This might sound really abstract, but it's actually pretty cool and often comes in handy. Say, for example, we don't just want to store the level of each player, but also other info like their health. Well, then we simply replace this value with another dictionary. So open and close some curly brackets. Here we'll add a key called level with a value of 1, and another key called health with a value of 80. And at this point, it's a good idea to use tabs to keep our code clean. Let's duplicate this. I'll assign some values. And now we can access a value by using two keys. Let's print the health of our boss, so print players. We go into our boss, and we access the health. And this prints 500, which is correct. So this way we can start to think of ways we can structure data about what's going on in our game, such as player stats, inventory, buffs, and so on. Enums. Enums are a convenient way to define tags or states in our game. Say we're making a game with a bunch of units, and we want a way to mark each one as either hostile, neutral, or ally. In this case, we could create an enum that defines these tags. So at the top here, I'll write enum to create a new enum, and then in the curly brackets, I'll write ally, neutral, and enemy. And now we can use these states in our game. For example, we can create a variable called unit alignment and set it equal to any one of these states. I'll just set it to ally. And this makes it really quick and easy to then check in our code if our unit has a certain alignment. Also, let's just give our enum a name here to stay organized. So we'll call this alignment. And now whenever we are accessing a state, we have to go inside of alignment dot, and here you can see our state. So I'll go alignment.ally by default. And then inside of ready, we can check.
Let's rename it, okay.
Is equal to alignment dot, let's check for enemy. And if it is, we will print, you are not welcome here. And if it's not, so it's not an enemy, we'll just write welcome. And now if we run, we can see that our console displays welcome because our unit alignment is currently ally. This is much safer than using, say, a string or an integer to represent states, because Godot will throw an error if we misspell a state. If, for example, I misspell enemy, we can see that Godot throws an error. But I think one of the real powers of enums is that we can use them for exported variables. To do this, we mark our variable here with export, and then set the type to alignment. And now we can actually set our unit alignment in the inspector. So I'm going to
that's so useful.
Now when we play, it prints you are not welcome here. Really cool. Now what's actually happening?
Wait, let's just set that up very quickly, because I want that in this demonstration. Export var unit alignment, and then that is of type alignment. And then if we save this, awesome, right?
Creating a constant for each state in our enum. So this code here is actually completely identical to our first line. And as you can see, the value here increases from 0 to 1 to 2, kind of like an index. So an enum is essentially just a bunch of constants with an increasing value, which means that if we try to print one of these states, say we print alignment.enemy, the console simply shows the value of that constant, which is 2, because it's the third state. This is rarely something you need to take into account, but it's nice to know what our code is actually doing. And we can even override the default value if we want. So we could set ally equal to 1, neutral equal to 0, and enemy equal to -1, and now our console displays -1 because that's now the value of our enemy constant. Now something that pairs really nicely with enums are match statements because they allow us to quickly add functionality for each state. Match. Match is the Godot equivalent of the switch statement from other languages. It allows us to execute different code depending on the value of a variable. In this case here, we can
we used to match in a previous
the variable we are matching based on
game attempt.
Colon, and now we add code for each value. So in case my alignment is alignment.ally, I'll print hello friend. If it is neutral, I'll print a common piece. If it is enemy, taste my wrath. And a cool thing here is that we can actually add a default response as well. To do that, we do _colon. And so if it isn't any of the cases above, we'll print who art thou? And if we set my alignment to say enemy, taste my wrath. Modifying nodes 2.0. So far, when we need to access a node, we've done so by simply dragging it into a script, which creates a $sign followed by the path to the node. I've created a few empty nodes here to demonstrate. A player node with a graphics and weapon node, and an enemy node. So if I drag in the weapon node, it creates a path that goes into the player and finds the weapon. And we can actually store this reference in a variable. To do this, we simply drag it to the top and hold down Control while releasing. This automatically creates a variable with the name of the node and the correct path. And as you can see, it uses the onReady keyword. This is because Godot has a very strict order in which nodes are created. And if we open the game and try to find the weapon node before it exists, we will get an error. OnReady simply makes sure that Godot waits until all child nodes have been created so we don't get any issues. And just a quick note, the $sign here is actually just shorthand for using the getNode function. So this is actually identical. Also, you might have noticed that the path is relative. Our script is on the main node, so it starts right after that node. We can print the absolute path through script. We'll print weapon.getPath. This prints the absolute path starting from the root of our game all the way to weapon. Now paths are great for many things, but sometimes they can be a bit inflexible. They break if we rename any of the nodes in the path, and it's best to only use paths when the node we want to access is a child of the node we're working on. We'll talk more about parent-child relationships later. Luckily, we can also use the export keyword to reference other nodes. So if we write export and create a variable called myNode, we can set the type to node. And then in the inspector, we can assign whatever node we want, or simply click and drag. I'll drag in the player. We can also check if the node is a certain type by using the is keyword. So in ready, we'll check if my node is of type node2D, in which case we'll print is 2D. And it is. We can even be specific about what
That's quite
we
useful.
want to be able to reference.
Let's have that as well in this sample. So export var. My node is of type node, and then if we save that and we add in just another, let's say a node2D, and we'll call this like player. And then we can drag this. No, if we have this, we drag this over here and save. So now this my node is a reference to the player in this script. Okay.
If, for example, we only want to reference sprite nodes, we just change the type to sprite.
So this is like serialized fields in Unity.
Sprites, which in this case are the graphics and weapon nodes. Now, if we play, it still prints that this node is a 2D node, even though sprite2D and node2D are two different nodes. This is because sprite2D inherits from node2D, but we'll get into that in the inheritance chapter. Signals. Signals are messages that nodes can send to each other. We use them to notify that a certain event occurred. It's probably easiest to look at an example. Godot has many built-in signals. Take this UI button. If we select it and go to node, we can see a list of all the signals on this node. I'm going to connect the pressed signal to our main script. So double click it, I'm going to select main and hit connect. As you can see, this creates a function called onButtonPressed, and over here there's a green arrow pointing to it. This means that a signal is currently connected to this function. If I click on it, we can see the source, which is our button. Let's just add a quick print line here, and now if we play and press the button, it prints money. Get it? Now this is because whenever we press the button, it emits the pressed signal, and everything connected to it gets called. In this case, our onButtonPressed function, which indeed prints money. We can connect as many functions as we want to a signal. They will all be called when it gets emitted. This is really cool because it allows us to link together nodes in a way where they don't have to be aware of each other. The button has no idea which functions are connected to the signal. It just tells it to emit. This makes signals great for separating different parts of our game, or decoupling. Say we're playing a character that can level up by getting enough XP. Whenever we level up, there are probably many game systems that need to update. The UI, our player stats, perhaps we have spells or achievements that unlock, and updating all of these from the player can quickly become a mess. Instead, we create a leveled up signal that all these systems can connect to. Then all we need to do is have the player emit the signal when we level up. Let's try it out. Instead of a button here, I'll create a timer.
Oh, wait. So that's completely the opposite way around from the way that we tried it. Where's our other projects? Can I open projects from here? Wait, can I not open other projects from here? Open user data folder, version control tools, reload, quit to project list. So yeah, let me quit to the list. I guess it doesn't really expect you to open multiple projects at the same time. So if we reopen up or relaunch Godot, I think this might be what we were doing wrong with our GMTK game. Let's have a quick look. So we're saying a signal emission is from the node that has the signal. Let's have a quick look at these scripts. So where was I using signal? I think in the player. Yeah, and then from the component we were emitting, weren't we? Hey, the Gamer Boy, how's it going? Thanks for the follow. Hope you're good. So yeah, maybe this wasn't the right way. Oh, right. Okay, so we're calling the emit of that signal remotely. Which kind of wasn't what we wanted to do, I think. But let's continue on and see.
And set it to auto start. This will count down from 1, and when it reaches 0, it emits a signal called timeout. Let's connect that to our script and make it increase our XP. So we'll create an XP variable, default it to 0.
Oh, we did some timers as well. That's fine.
And let's also print it. If our XP then reaches, say, 20, we'll set it back to 0, we leveled up, and we can start over for the new level. And if we then play, it's going to increment our XP every second, and when we reach 20, it's going to go back to 0. Now let's create a signal that other nodes can connect to. So at the top, we'll write signal, leveled up, and if we save this and select our main node, we can actually see that signal. We can connect it to other nodes, but just for this example, we'll connect it back to our main node. This creates an onLeveled up function, which is called when the signal is emitted. Let's print a message that says ding. Now we simply have to emit the signal. Let's do that when we reach 20 XP.
Cool, okay.
Leveled up, dot emit. Now when we reach 20 XP, it emits the signal, and we print ding. Awesome. We can also connect signals through code. I'll disconnect the signal in the editor, and instead, in a ready function, I'll write levelup.connect and the name of the function we're connecting to, on leveled up. Careful here, this will probably autocomplete with parentheses. We don't need those, we just want the name of the function. And disconnecting is just as easy, disconnect. We can also pass parameters through signals. This could be used to pass the level we reached or other useful information. I'll just add a quick message that we can print. So on a signal, we'll add a parameter. We'll make sure that our function supports this as well. And instead of printing ding, we'll print whatever message was input. And then when we emit the signal, we can put in a message. Let's put in grats. And voila, it displays grats. And that is signals.
That's very useful.
Or just get set. Getters and setters allow us to add code for when a variable is changed. This means that we can do things like clamp a value within a certain range, or emit a signal letting other parts of our code know that the variable changed. The example that is always used for this
We might come back to bits of this.
Variable, default it to 100, and then we'll use a colon to go and define a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to, and now we can decide what to do. We could, for example, set our health equal to not the value directly, but clamp it first between 0 and 100. So this makes sure that our health does never exceed 100 or go below 0. We could also emit a signal here, so we can create a signal. Health changed, and we can actually input the new health as a parameter, and then in our setter we can go health changed dot emit and put in the new health. Of course, we need to make sure to connect this signal. We can do that through the editor, and let's just print the value. So we'll print the new health. Then in ready, let's try this out by assigning a value to health. Let's try assigning -150, and now if we play, we can see that it prints 0. This is because we put in -150, it clamps this to 0, and then it emits the signal. The signal then calls the onHealthChanged function, and we print the new health, which is 0. So that's a good example of adding a set. Getters are more commonly used to convert values. So let's add two variables. We'll have a chance that is equal to 0.2, and then we can have another one, which is our chance in percent. We'll make this of type int, and we will add a getter. Here, whenever we try to get the chance percentage, we'll simply return the chance variable times 100. And now if we try to print this variable, print chance percentage, or change our chance to, let's say, 0.6 and print it again, we can see that our chance percentage is completely based on whatever our chance is currently equal to. And so it starts at 20% and then goes to 60%. And for good measure's sake, we'll add a setter also. So if we set to a new value, we will modify our chance and set it equal to the new value divided by 100. And since our chance is a float, we'll make sure to cast that value. So now instead of changing the chance, we can directly change the change percentage to, say, 40. There we go. Classes. This is a good one. GDScript is an object-oriented programming language. This means that we generally try to structure our code in self-contained objects that interact with each other. We primarily do this using classes. For now, try to think of a class as a blueprint. Say, for example, we're making an RPG and we need to populate it with a bunch of characters that the player can interact with. So we create a character class that has some variables and logic that all characters in the game should have. So for variables, we could add things like name, health, and a line of dialogue for when you interact with them. For logic, we could add functions like talk and die. Then we take this class and create instances. Instances are specific versions of the class. So we could create an instance named Potion Seller that has a health of 50, and a line that says, you can handle my strongest potions, and a bunch more instances, all of which have the same variables, but different values, and all of which can talk. I used to be an adventurer like you, and die. So that's the idea of classes. In Godot, you've actually already encountered a bunch of classes. That's because all the built-in nodes in Godot are classes, which actually makes a lot of sense if you think about it. All the nodes are self-contained objects with a bunch of variables and logic that we can create instances of. If we add a sprite node, we're instancing the sprite class. So when we create a script, we're actually also creating a class. I have to put a disclaimer here that we're technically not creating a class, but for all intents and purposes, it works just like one. So let's forget all about that for now. So let's abandon our main script here for now and instead create a new node. So search for node and let's name this node character and add a script to it. Now to make it more clear that our script is a class that defines a character, let's set the class name to character. So right at the top here, we'll go class name, character with a capital C. And we can now add some variables. We'll mark these with export so that we can set them in the inspector for each character instance. So export var, let's add a profession of type string and give each character a health as well of type integer. And so now we can see that our character here has these two properties in the inspector, and we can go ahead and fill out the profession. This is going to be the potion seller, who is going to have a health of, let's say, 40. And now we can create more instances by duplicating this node. So let's duplicate it a few times. The second character here will name X Adventurer with a health of 30. And the last character will be our knight, and we'll give him a health of, say, 150. So now we have these three instances with different properties, and we can also give them a function. So let's add a die function. So I'll write func die, and this function is going to set our health to 0, as well as print our profession and the fact that we died. And that's it for our character class, but currently nothing is triggering this function. So let's go into our main script now, and here we can get a reference to one of our characters and call the die function. We could simply drag and drop one of these nodes to get a reference, but because we have named our class, we can actually use an export variable for this instead. This way we can set the connection in the editor, and we don't have to worry about the path changing. So we'll write export var, and here we'll have a character to kill of type character. And now if we save that, we can see that our main node now has a slot here for the character to kill. And we can either drag in one of these characters or hit assign and select one. I'm going to choose character 3. And now in our ready method, we simply go to our character to kill and call the die function. And if we run this, indeed, the die function is called on our character 3, which is our knight. So it says knight died. And if we choose another character, say the first one, we are instead killing the potion seller. Really cool. Inner classes. These are classes that exist inside of another class. We mostly use these for bundling together variables and maybe add a function or two. They can be a good alternative to dictionaries because they are sometimes a bit more safe to use. Say we have this character class here and we would like to add some equipment. We could create an inner class called equipment. So I'll write class equipment and then we can give it a couple of variables. I'll create an armor variable, set it to 10 by default, and a weight of 5. Now we can use this class around our script. So we could create some variables using it. I'll create a chest that is equal to equipment.
So a lot of this is going to be based around figuring out the structure that you want to data,
also create legs, and again we'll call equipment.new. Then in the
which will depend on the game, obviously.
We can go into our chest and change the armor and set it equal to 20. We can then print chest.armor, or maybe print legs.weight. And this is also where you can see that this is sometimes safer than using a dictionary, because GDScript will recognize that there is a weight variable inside of the equipment class. And if we try to access something that isn't there, we'll get an error before playing the game, not only when we reach this point in our code. This is called being type safe. And now if we run this, we can see that each of the instances of our character will print these two pieces of equipment. And the armor of the chest is 20, and the weight of the legs is 5. Inheritance. So we know that all nodes in Godot are classes, and we can effectively make our own using scripts. But there's one more important thing we need to know to understand how Godot is structured. Inheritance. Inheritance refers to the ability to derive one class from another. We've actually already been doing this. Notice how our script says extends node. So our script derives from the node class. This means that all the functions and variables of the node class are also available in our script. Godot actually has a very nice way of visualizing this. When adding a new node, we can see all the nodes available to us, but some of these are organized under other nodes. That's because these nodes inherit from the top ones. For example, both animated sprite 2D and camera 2D inherit from node 2D. This is because node 2D is a base class for all things that exist in 2D space. So since both a camera and a sprite needs a position in our world, they both inherit from it. And even cooler, we can actually find our character class on this list as well. That's because when we create a character class, we're essentially defining a new node type, and we can see that it inherits from node. Really cool. Now, all of this probably sounds a bit abstract, because it is. But what it means in most cases is simply that we need to make sure we inherit from or extend the right class for what we're working with. If, for example, we're making a script that moves around our player, we would create a character body node and add a script to that node. We could name it, say, player. And as you can see, the script then automatically extends character body 2D. And we now have access to all the functionality in it, such as the velocity and the move and slide function, which moves the node around. Composition. Now, even though Godot uses inheritance for nodes, there are often better ways to structure your code. Godot actually leans itself really well to another way called composition. I'm not going to explain that here since there's already a really good video on the subject by a channel called Bitlytic, but I definitely recommend you check that out. Call down, signal up. When writing,
you might have to wait. Have we got a link to that? Composition. Here we go. Might continue on to that after.
Going over all of them is a video on its own, but one that is particularly important is call down, signal up, which we use as a rule of thumb when communicating between nodes. Every scene in Godot is a tree of nodes, and the beginning of the tree is called the root node, which is the highest in the hierarchy. When looking at two nodes where one is right above the other, we say that they have a parent-child relationship. The node that is above is the parent, and the node that is below is the child, and that child might also have a child, and so on. Call down, signal up means that nodes are fine to call functions on the nodes below them in the hierarchy, but not vice versa. Instead, nodes below should use signals to communicate that something has happened. The nodes above can then connect to these signals as they choose and act accordingly. Think of it like real life. Parents are allowed to tell their children what to do, but children shouldn't directly command their parents to do things. Instead, children signal their needs to the parents, and the parents decide the next step. Now keep in mind that this is a way to remember good coding practice. It is definitely not parenting advice. But what if we need to communicate between two nodes that are on the same level? Guess that these are called siblings. Well, here the common parent is in charge of connecting the signal from one sibling to the function on the other. This is most often done in the ready function right at the beginning. So that's the idea of the rule, but of course always implementing this concept correctly requires some practice. I'll have a link to a good article with some nice examples. Style. During this video, I've tried my best to adhere to the
So more on cooldown. Signal up, okay, and then style. Oh, style guide's going to be useful as well.
GDScript style guide. These are the conventions we use for naming and order to keep our code elegant and readable for others. I won't go into further detail here, but I'll have a link to the official guide. That was a lot of code for one video. Of course, I have everything you're ever going to need in GDScript.
Really good coverage, and also the fact that there's a style guide is something that's quite useful. Let's get some music back on, and we'll probably have to drop the audio value a little bit on that when it starts. Let's drop that down to about there. We're gonna get some music. Yeah, there we go. Ooh. Right, so let's have a quick look at that then. I think we can bring this back into the main screen now. Let's turn that to reset screen for a second. Okay, so class names being, what's this, camel case, Pascal case? Can't remember which way around it is. But first let's capitalize no spaces. Guide is inspired by Python Pep8. Okay. Then variables all lowercase underscores. Oh, pretty much everything lowercase underscores. That's fine. Just gonna have a quick read through this. Exceptions to this rules are arrays, dictionaries, and enums. Use a single indentation level to distinguish continuation lines. No, wait, this. Use 2 indent levels to distinguish continuation lines from regular code blocks. Okay. So because this is all within the same bracket, rather than having it spill over to the next line, it shows that it's still continuing from the previous line. Okay. That looks fine. Trading commas in, yep. Yeah, basically, so that if you add anything to the array, the comma change on this line won't show as a line change. That's the main reason for that. It's fine. Blank lines. Surround functions in class with 2 blank lines. Okay. One statement per line, that's fine. Only exception is ternary, but ternary's not great anyway. Multi-line statements for readability, that's fine. Yeah, okay, it's still pretty basic. Documentation comments with double hash symbols, that's fine. White space. Don't use spaces to a line, that's fine. Quotes. Use double quotes. Don't omit the leading 0, okay. Or trailing zeros, that's fine. Use lowercase for letters in hex numbers. as the lower height makes it easier to read. Okay. I've not considered that before, actually. But actually, yeah, I can kind of see that. Oh, you can add underscores to make things more readable. That's very useful. So the underscore is ignored in like an integer read. Use snake case for file names. Yeah, okay. For names classes, convert the Pascal case name to snake case. Yeah. Use Pascal case for class and node names. That's fine. When loading a class into a constant or a variable. Snake case. Append a single underscore to virtual methods. Functions the user must override private functions and private variables. Use past tense to name signals. Okay. Enums and constants are capitalized. Right, enums with each item on its own line for version control that's easier. Case order. Wow, they've even got case order of this. Okay. So I don't know what tool is. I've not seen that. So class name, then extends, then signals, then enums, then constants, then exported variables, public variables, private variables, on-ready variables. Most of these would probably not use. Oh, wait, these are methods. Okay. Built-in virtual init method, and tree method, ready method. Remaining built-in virtual methods, then your own public methods. This isn't as important, but it's just useful to have like a baseline. Class extends, it's fine. Signals and properties. Okay, so what do we want to do now? This is all the signal up, cool down information, that's fine. So we might read through this at some point, but probably not too much. And then this is about composition. This is only 6 minutes, so let's do this video as well.
Are two tactics used in programming to reuse your code as much as possible.
Let's pause that.
Widespread, but I think
Probably need to bump this
composition would
audio
be
up
a
a little
little
bit.
bit better. Let's say we have this setup. We have a player, and this player can attack, has health, and a hitbox. Alongside that, we can accept user input. And similarly, we have an enemy. This enemy can attack, has health, and also a hitbox, as well as some enemy-specific stuff like AI. In the world of inheritance, we would take the attack, health, and hitbox and drag them out to their own individual class. We'll just call this class entity, and the player and enemy will extend from this class. This moves all our code into one easy to change spot, so if we ever have to modify the code, it'll affect both the player and the enemy at the same time. We don't have to go digging through every class that has the ability to take damage. And if that were the end of the story, inheritance would be the perfect solution. I mean, right now, this is really easy to comprehend. But let's bring in another object. Let's say we have a tree, and similar to the player and enemy, the tree can take damage. So we can extend entity, but this causes a small problem. While we do have the health and the hitbox, now we also have the ability to attack, which we probably don't want from a tree. There's also a more potent underlying issue. Because we're using Godot, both the player and the enemy extend character body 2D, whereas the tree extends static body 2D. In the world of inheritance, at least in Godot, you can't extend from multiple classes. Since player and enemy both need their own character body 2D code, entity must also extend character body 2D. However, since tree also extends from this entity class, that means it must also be a character body 2D. There's a few ways around this, and the most straightforward approach is to change tree from a static body to a character body. This isn't ideal though, because this gives the tree the ability to move. Alternatively, you could extract the entity class out into a static entity and a character entity, and decide which classes need to inherit from where. But as you can see, this is already getting a little bit complicated, and all we did was add a tree. There's gotta be something better. Let's rewind a bit. Instead of using inheritance, we'll approach this with composition. Instead of making one superclass, you instead make multiple components. So for example, we would have an attack component, a health component, and of course a hitbox. Then the player and enemy would both just have their own list of components that they need. In this case, we have 3. Let's bring back in the tree from the earlier example. Because components don't care what class you're extending from, we can simply attach a health component and a hitbox component to the tree. And we're done. That's all the hierarchy we gotta worry with. You can see in this case, this is a lot more preferable to inheritance. And there may be a few odd things, like telling the hitbox component where your health component is so it can send information about taking damage, but I think that's a valid trade-off. In Godot, each of these components would actually be a child of the player, enemy, or tree node, and you can arbitrarily attach them to any node that you feel needs these components. So for example, let's say we bring in a bullet. Well, for the bullet, we want an attack component, but we also want a hitbox component. It doesn't matter how much HP a bullet has. If it hits something, it's going to destroy itself, so we don't need a health. This is the basic idea behind composition. Let's go ahead and jump into Godot, and we'll build through a project where we use composition. Alright, back in the project from last video, I've gone ahead and removed any reference to the damage functions from before. I want to build back the damage functions from before, but using composition as a base. First off, I'll add a new node 2D to the enemy and call it health component. I'll also add a new script to this. Starting off with the script, we'll add a new health variable, a max health, and inside of the ready function, I will set health to max health. Then I'll add a damage function and take in an attack from last video and subtract that damage from the health. Then, if the health ever drops below 0, the parent will free itself. Back on the enemy, we'll add a new area 2D object and call it hitbox component. You may notice a warning about the shape, but we'll get back to that later. We'll attach a new script to it. We'll start by exporting a health component variable, then add a damage function, also passing in an attack like before, and then we'll check if the health component exists. If it does, we will call .damage on it. And the health component variable can be set in the inspector, like so. One thing I don't really like about this is we can attach any node 2D to this health component variable. And for example, if I attach the sprite 2D, this would crash because sprite doesn't have a damage function. So instead, one thing we can do is inside of the health component, we can declare a class name health component. Then instead of just using any node 2D, we can specify
This
that we want
kind of
specifically
setup
a health component.
seems to be
Then inside of the inspector, you can see that
seems
it
to make a
only
lot more
highlights
sense to
things
me,
that
and it gives a
classify
lot
as
more
health
power to
components.
extend.
It's also nice because this gives us IntelliSense. So if I do control space inside of this function, we can see what it expects. Or if I control click damage, it will take us to the declaration. Let's go ahead and save these off to their own branches as health component scene and hitbox component scene. One thing you may run into is if you previously assigned the health component and you go into the hitbox component scene, you'll see that it's already pointing towards a health component. You can leave this if you want, but it may cause issues in the future. So I usually just clear this and assign it for every enemy that I create. Alright, let's talk about this warning now. So a hitbox needs a shape, and your first instinct might be to put it inside of the actual scene. And while that would work, this means that every enemy and every object that uses hitbox component would have the exact same hitbox shape. Instead, what we'll do, in the enemy scene, we'll actually attach a collision shape as a child of the hitbox component here. This allows us to use unique hitboxes for every single object. Inside of the scene, you can also set up collision through here, or you can do it in the enemy. So for example, an enemy and a player would want different collisions, so you can set it in their respective scenes. And the last thing I'll do is set up my weapon to attack a hitbox. So for this, I'll check whenever we collide with an area, we'll check if it has the function damage, and if it does, we'll construct a new attack like before, and call the damage function passing in the attack. We can also do something neat with this code. If I head back to the hitbox component, we can also declare class name hitbox component here. Then inside of the weapon, instead of checking whether it has the method, we can see if it's a type of hitbox component. If it is, we'll pull it out into a variable and call .damage on that. This has the same benefits as before, where we can do control and space to see what the function wants, or we can control click it to see where the function is declared. And that's actually all we need to do for composition.
That's quite useful, yeah.
I can hit it. I'll also throw together the tree and the crate just to show you how easy it is once you've got these nodes set up. I'll start by dragging in a health component and then a hitbox component. And inside of the health component, I will set the health to 30. And inside of the hitbox, I will drag in the health component. Then of course, I'll add a shape to the hitbox, give it a capsule shape, and fit it to the tree. Then of course for the crate, we can drag in a health component and a hitbox component. I'll attach the health component and set the HP to 20. Then I'll add a new collision shape of a rectangle.
I imagine rather than doing these as separate components as well, what you could do is combine a separate scene. Oh, but then you wouldn't be able to attach the collision to the hitbox component, would you? I'm just thinking like, maybe if you've got static objects that you know will always have a health component and a hitbox component, you could combine them together. So then you just add a static object component, for example. But I don't know.
And just like that, if we go in the game, it takes 3 hits to kill a tree, 2 hits to kill a crate. Hopefully this shows you how powerful composition can be. Of course, it isn't one size fits all. Sometimes inheritance is better, sometimes composition is better. But of course, that's how everything is in game development. Hopefully this makes game development easier for at least someone out there. And as always, have a good one.
Nice. Cool. All right. So what do we want to do? For the rest of this. Well, we can close this. We could play around a bit more in some scripts, but I think that's less useful. Could go back to this game and tidy it up and see how we're getting on, and add things like enemies and just start working towards that. I think that seems better. Or we could do some play rating, or we could do some pixel art. So let's have a quick look at the Brackeys Game Jam. Oh, I hate this. I don't want that set up. There we go. Right, so this is in 9 days. 8th to the 15th. This game jam, you make a game based around a set theme in just a single week. After submitting your game, it will get rated by other participants and you get to vote on other games. Game jams, fun way, yeah. Give it a shot, it's always worth. Let's get ready for your first game jam. Join the Discord server for notifications. After this jam is based around. So we've already had a look at this. Let me just drop that music down a little bit. That's a bit loud. Your game must not include any not safe for work or offensive discriminatory content, which for games to be playable by everyone. Apart from that, you're allowed to use any game engine or framework. You can use assets not made for you, but make sure you have proper license, and crediting is encouraged. Making from scratch is not mandatory. If you do, you get to be extra proud of yourself. Okay. Teaming up is allowed and encouraged. Our recommendation is set with 4 people max. Do note for submissions, if you submitted your game, do not delete it. If you delete your game, you're out of luck. Also know that linking to an external site will disqualify you. So make sure your game is uploaded to itch if you want to participate. There's no grace period for submissions, that's fine. Game files are not locked, so if you discover a major issue with your game, it's possible to change this afterward. Just make sure to make a submission before the deadline. Yep, that's fine. It's only for game breaking issues. Don't use this feature to otherwise update your game before the rating period is over. Games rated in 6 categories: game design, fun, innovation, theme, graphics, and audio. You have 2 weeks to rate games, at least 20 ratings to be eligible to win. Cool, okay. Pretty standard. What's in the community tab? Let's just have a quick look at some of these. See what people are looking for. Well, it's quite good for finding other team members. Okay, I reckon what we're going to do then is go back to this GMTK game and review what we've done so far, like tidy stuff up, and start thinking around how we would compose the game. But I think I'm going to do a little break first. So probably do like a 5-10 minute break. Just to stretch, get a drink, go to the loo, etc. So let's be right back. What have we got? Be right back on this. Vaccine. Countdown timer. No. This timer. Cool. Alright, back in a sec. Right. So I'm kind of in two minds here. Either continuing on with the GMTK game idea, which I don't have like a great idea of what we're going with that. Or the other thing that I was thinking of is going back to some old Game Jam games that I didn't really finish properly. Because we've already got like some of the assets for stuff that. So this was like the point and click adventure one. But maybe we can retry making those and developing them a bit further. I got Harvest there as well. Because a lot of those I didn't really get anywhere with. Like, there were lots of ideas of what to do. And even King of the Ring. So I don't know if I've got the pixel art for that. Because these were just the little animations, but that was the very first one. Oh yeah, New Warner. Oh, I don't know which one. Where was there was another one as well. Maybe we've not got it in this computer. Okay, I need to make a decision. Let's just continue with this, but maybe let's re-figure out what we're doing with it all. I'm going to boost the music just a little bit. I think it can be a little bit louder. It's not too bad. Okay, what we're going to do is think about what we're doing with this game. So thinking about like finding blueprints to create tools. We're going to have that machine that changes the size of things. Lab setting, horror, dimly lit player. It's player animations, isn't it? Yep. Okay, and where did we get to? Is it even going to run at the moment? Because we started trying to do input manager stuff. Yeah, okay. And then I thought we don't have an interact. Oh, we have some interacts. That works. And changing the setting. Wait, why was that not working here? Only while we're facing this way. That's weird. Why is that not giving us the option here? But if we turn around, it does. Okay, well, there's going to be bugs in this anyway, so They're in the doorway, that's fine. Okay, so technically this is like a this is a test scene, so maybe we rename some stuff. I feel like all of this we kind of have gone a bit in the wrong direction with some of this setup. So it might be easier just to like start a new game file. Okay, no, let's continue with this. Let's get rid of this component thing. I think scripts wise and really this like scene, the file setup is a bit wrong. So that's for exporting. Those are those add-ons, that's fine. Okay, let's work on a door. That's the first thing. It's fine. So is open function here. So the states, maybe let's have a state enum. Which I don't think I have to do equals, but it's locked, open, closed, or locked, closed, open. Are there any other states that we'd need a door to be in? Don't think so. And then, yeah, this is what we're starting to look at. Rather than worrying about inputs, we give signal outputs. So I think really we're going to be getting rid of all of this, but we'll leave it in for the moment. And let's do a function, and let's call this unlock door. So then I guess if our state, if state.locked, then okay, wait, we need a current state variable, right? Current states, type states. and that should be an export. So when we put it in the world, we can choose whether it's a locked or unlocked or open door. So if current state equals locked state or locked, double equals, then current state becomes equal to state dot closed. And that's it, really. And then I guess we could have like a lock door function. If current state is state.closed. Oh, need a colon. Let's just get used to writing some functions like this. State.locked. Ooh. So really, we'd want some signals here to emit to other parts or to other scripts what's happening. Maybe. I'm not entirely sure on that. How do we do optional parameters as well? Can we do something like func toggle lock, let's say, and then this is an optional parameter, which is a boolean. So force state bool. And how do I make it optional? Like a question mark? If for state let's have a quick look. Optional parameter. Let's have a look online. GDScript optional parameters. I mean, it sounds like this is pretty good. Oh, so you set it to a value? Right, okay, so you set it to a value and that tells it whether or not it's optional. So it can't be a bool here. So let's do another enum. And this will be for lock state, lock interaction. Let's call this interaction. And this will be lock unlock, open, close. And we'll do full state interaction. Oh, and toggle. We need toggle. And by default, we're going to set this to lock. No, interaction. Dot toggle. So if full state equals interaction dot toggle, let's say, then if current state might skip this song, it's a bit, it's meant to be like a glitchy part by the sounds of it. So if current state is state.locked, then so rather than for state, let's call this interaction yeah, we can just call this interaction, or let's just call this action. Right, so action is toggle there, and it's locked. Action becomes equal to state, no, interaction dot unlock. Elif current state equals equals state dot lock, no, state dot closed, then action equals interaction dot lock. And that's it. If the state is something else, so if the state of our door is open, then you wouldn't be able to lock it. Okay, so now let's start with toggle. And then here, in action equals interaction dot lock. Then we could do here things like test if player has required key. If not, we call lock door. And then L if action equals interaction dot unlock. Again, we do the test if player has required key. And then call unlock door. Okay, but really, why do you, oh, you want a colon here? So actually, this whole thing should be tested player has required key up here when we come into this, because otherwise we're not doing anything at all. But this toggle lock we can call with the action of lock as well to try and force the lock rather than to toggle. Okay, so that's pretty simple. Still trying to get my head around what happens in terms of this kind of stuff here. So rather than player detected input action pressed, we want to subscribe to a signal. And this signal would be of a sibling element in the world from the player. Right? So let's go back to that video here. So I kind of want to see the signal stuff. And how this works a bit.
Godot has many built-in signals. Take this UI button. If we select it and go to Node, we can see a list of all the signals on this node. I'm going to connect the pressed signal to our main script. So double-click it, I'm going to select main, and hit connect. As you can see, this creates a function called onButtonPressed, and over here there's a green arrow pointing to it. This means that a signal is currently connected to this function. If I click on it, we can see the source, which is our button. Let's just add a quick print line here, and now if we play and press the button, it prints money. Get it? Now this is because whenever we press the button, it emits the pressed signal, and everything connected to it gets called. In this case, our onButtonPressed function, which indeed prints money. We can connect as many functions as we want to a signal. They will all be called when it gets emitted. This is really cool because it allows us to link together nodes in a way where they don't have to be aware of each other. The button has no idea which functions are connected to the signal. It just tells it to emit. This makes signals great for separating different parts of our game, or decoupling. Say we're playing a character that can level up by getting enough XP. Whenever we level up, there are probably many game systems that need to update. The UI, our player stats, perhaps we have spells or achievements that unlock, and updating all of these from the player can quickly become a mess. Instead, we create a leveled up signal that all these systems can connect to. Then all we need to do is have the player emit the signal when we level up. Let's try it out. Instead of a button here, I'll create a timer. So I'll add a timer node and set it to auto start. This will count down from 1, and when it reaches 0, it emits a signal called timeout. Let's connect that to our script and make it increase our XP. So we'll create an XP variable, default it to 0. Then in our function, we increase our XP, and let's also print it. If our XP then reaches, say, 20, we'll set it back to 0, we leveled up, and we can start over for the new level. And if we then play, it's going to increment our XP every second, and when we reach 20, it's going to go back to 0. Now let's create a signal that other nodes can connect to. So at the top, we'll write signal, leveled up, and if we save this and select our main node, we can actually see that signal. We can connect it to other nodes, but just for this example, we'll connect it back to our main node. This creates an onLeveled up function, which is called when the signal is...
Right, okay, so if we want this to work this way around, right, we can close this one. Don't need this open anymore. So we want from our player. Oh, actually, we need to update our little message here. But we want our signal from our player. So I think let's kind of ignore this stuff. It's a problem. There's going to be so much dead code in all of this. They said put the class name first. So if we had signal of interact, and another signal of secondary interact. Wait, how are we doing the input manager stuff? Player direction dot emit. So handle input this. I'm gonna keep getting confused between these scenes and the script files. I don't mind this actually. This kind of setup where the input is handled. So what are we passing? We're saying if it's sprinting and the direction, then we do a direction input. So if events.isAction pressed, we've typed player interact, then player dot interact dot emit. And then if event.isAction pressed, and then it's player up, we're going to do player.interact, no, secondary interact dot emit. Drop that down a little bit loud. So then, how do I find the right signal for this though? We go like player, interact, and connect. Then it links it to this script. But can I do it? Can I link it directly to the door? Disconnect. Connect to script. So I can't go outside of the player scene where the script is. How do I go up? Is that where this... No, this one. I think that's what this tutorial was covering. When it starts to get complex, you have multiple scenes instances in a lot of nodes. You probably find yourself writing code like get node, some node, other node, get parent. If you do this, you'll find node references like this break easily as soon as you... Yeah, okay, solution. As a general rule, nodes should manage the children, not the other way around. If you're using get parent or get node, then you're probably headed for trouble. You can't test independently. Can't change things easily. Ready order is child first, parent last. Generally speaking, a node or scene should be able to get instanced anywhere in your game and should make no assumptions as to what its parent is going to be. Hence detailed, yeah, okay, so cooldown, signal up. If a node is calling its child, that's fine. If a node needs to communicate up the tree, it should probably use a signal. So using get node, traverse the scene given path. Let's consider the following common configuration. So you have a player script, a player node with animated sprite 2D node and a collision shape node. And the script in the player node needs to notify animated sprite to play that. That works well because you're going down the tree, that's fine. A better way, okay. Downside of this approach, you have to specify the node path, and if that changes later, you have to edit the code as well. Instead, you can use the Xbox and to directly select the node. With this method, you assign the variable directly in the inspector. Using signals, should be used to call functions on nodes that are higher in the tree or on the same level, i.e. siblings. You can connect a signal in the editor or in code for nodes that you're instancing at runtime. The syntax for connecting signals is signal name.connect target node.target function. If I'm connecting to a signal, I won't need node paths like sibling. Well, you could do this, it breaks our rule above. Against this puzzle, make sure the connections are made by the common parent. Okay. Following the rule of calling down the tree, a node that is common parent to the signaling and receiving nodes will by definition know where they are and be ready after both of them. Updating UI. Whenever your player's health variable changes, you want to update a label or progress bar to display. However, your UI nodes are completely separated from the player. The player knows nothing about where those nodes are and how to find them. Okay. This way often sees things like get node UI, yeah, okay, which is what we want to avoid. Instead, the player emits a health change signal wherever it loses health. We need to send that signal to the UI's update health function, which handles setting the label function. In the player script, we use this code, emit health, yeah. In the UI script, we have that function, so now we just need to connect it. Perfect place is in the world, which is the common parent and knows where both nodes are. Groups are another way to decouple, especially when you have a lot of similar objects that needs to do the same thing. A node can be added to... Okay, right, yeah, this is what we want to do. Groups are a tagging system. A node is in a group if it has that tagged assigned from it. The scene tree keeps track of the tags and functions like get nodes in groups. Let's consider Okay. So get tree, call group enemies, and all of the enemies have an explode function, and you do it that way. I'm going to skip this song. Bit intense. Okay, so that's one way of doing it for lots of groups at the same time. Lots of... Okay, slightly different to what I thought it was. I think that I was probably thinking this kind of thing where you can assign... Basically, where we could assign like a door to a group while it's interacting. That's not what we want here. Using owner. Owner is a node property that automatically set when you save a scene. Every node in that scene will have its owner set to the scene's root node. Buttons here are instances of a button scene representing an object which may contain dynamic code that sets the button's text or other properties, or perhaps you have buttons that are dynamically added and removed from the container depending on the game state. Regardless, all we need is to connect the button's signal is the following. Okay. Let's just have a quick look through this again. So how does the player on hitbox area entered? Yeah, okay, this.
Area. Check if it has the function damage, and if it does, we'll construct a new it.
Right, this is okay. Area has method damage. So rather than this input event, oh god, trying to wrap my head around this. It's probably something quite simple, but just not focusing on it. So if area has method damage, last name hitbox component extends area. So actually from the player, can we do something like function handle interact? It's a weapon. Because we have the player detecting the collisions. Does that really help? Message when the received body enters the area. Body can be physics studio or tarmac. Tarmac's okay. So can we just do like function handle maybe just call it interacts? And this just calls toggle lock, let's say. Or actually, we want this to be toggle open. And then we'll do a secondary interact. Secondary interact, which is toggle lock. For the moment, we need a toggle open, but let's just say we do a print debug door unlocked. It's probably a much simpler example I could have been doing. That would make it a lot easier. Door locked. And then toggle open is going to be pretty similar. So we call this toggle open. So interact. So if current state is closed, we want to open. Else if it's open, we want to close. I don't like we've got open and open. Maybe let's call this opened. We can update where we need to. And then if interaction is open or close, then this is going to be open door or closed door. Maybe. And then that's basically these ones. So we can open it, we can lock it. So actually, our interact here, no, secondary interact, needs to check the state as well. If, so current state is, if it's state dot opened, then we entered the door. And then for any other state, we're toggling the lock. So now we just need our open and close door, which we're just going to copy these for a second. Let's call this open door. Let's call this closed door. So current state is closed. It's now opened. This is door opened. It's a very verbose way of writing this all out, but that'll be alright for the moment. Door closed. And then we can play the opening animation or play the closing animation, which is open backwards in here. And then we're getting rid of all of this. Oh. We don't need that because we've got it in our state now. So then all we need to do is see if we can trigger our interact or secondary interact. And interact needs to check if current state is not equal to state.locked. Then we can toggle it. So I feel like this gives us a good setup for an interactable object, for example. But then how do we link it? So in this example, on hitbox area entered, so from the player, Can I check for collisions on the player? Input events. Why mouse shape? Miss it when the mouse pointer enters any of this. No, I don't care about the mouse. This is extending character body TD, right? I feel like I'm so close. So I've got a reference to our player here. On body entered. Can I say that it has to be of type player? Could not pass global player from... Can I test if it's type? If body class name hit. Okay.
Hitbox component here. Then inside of the weapon, instead of checking whether it has the method, we can see if it's a type of hitbox component.
If area is, okay. So I can say here, if body is player. Then that's true and that's true. Could not pass global class player from this. Why not? Function on body area. If area is hitbox. So see that passed it here. That's not what we want. Still not understanding this properly then. Oh, right, okay. Because there's an error here. Because of this. If we just do pass for the moment, save that. Does it stop complaining? Yes. Okay. Right. That's better. Okay. If body is player, player is set to true. I guess we should do the same here. So we know it's the player entering and leaving the doorway. Disconnect that. We don't need that. Right. So then how do we detect the signal from the player? This signal is being emitted. But in the scene, the door and the player are siblings, so the game needs to tell them. Which should really be our game manager script, right? That doesn't seem right to me. Let's just get rid of that for the moment. That's fine. Just tidy this up a little bit. Right, let's go. Let's really rewatch this signals bit because it's still not completely there for me.
Take this UI button. If we select it and go to Node, we can see a list of all the signals on this node. I'm going to connect the pressed signal to our main script. So double click it, I'm going to select main and hit connect. As you can see, this creates a function called onButtonPressed, and over here there's a green arrow pointing to it. This means that a signal is currently connected to this function. If I click on it, we can see the source, which is our button. Let's just add a quick print line here, and now if we play and press the button, it prints money. Get it? Now this is because whenever we press the button, it emits the pressed signal, and everything connected to it gets called. In this case, our onButtonPressed function, which indeed prints money. We can connect as many functions as we want to a signal. They will all be called when it gets emitted. This is really cool because it allows us to link together nodes in a way where they don't have to be aware of each other. The button has no idea which functions are connected to the signal. It just tells it to emit. This makes signals great for separating different parts of our game, or decoupling. Say we're playing a character that can level up by getting enough XP. Whenever we level up, there are probably many game systems that need to update. The UI, our player stats, perhaps we have spells or achievements that unlock, and updating all of these from the player can quickly become a mess. Instead, we create a leveled up signal that all these systems can connect to. Then all we need to do is have the player emit the signal when we level up. Let's try it out. Instead of a button here, I'll create a timer. So I'll add a timer node and set it to auto start. This will count down from 1, and when it reaches 0, it emits a signal called timeout. Let's connect that to our script and make it increase our XP. So we'll create an XP variable, default it to 0. Then in our function, we increase our XP, and let's also print it. If our XP then reaches, say, 20, we'll set it back to 0, we leveled up, and we can start over for the new level. And if we then play, it's going to increment our XP every second, and when we reach 20, it's going to go back to 0. Now let's create a signal that other nodes can connect to. So at the top, we'll write signal, leveled up, and if we save this and select our main node, we can actually see that signal. We can connect it to other nodes, but just for this example, we'll connect it back to our main node. This creates an onLeveled function, which is called when the signal is emitted. Let's print a message that says ping. Now we simply have to emit the signal. Let's do that when we reach 20 XP. Here we'll write leveled up dot emit. Now when we reach 20 XP, it emits the signal, and we print ping. Awesome. We can also connect signals through code. I'll disconnect the signal in the editor, and instead in a ready function, I'll write levelup.connect and the name of the function we're connecting to, on leveled up. Careful here, this will probably autocomplete with parentheses. We don't need those, we just want the name.
So this is saying the leveled up signal we're connecting to our function. Ah, wait. That's what we could do. We could do here, play detected. So body dot interact dot connect to our interact function. Oh, maybe wait, this might be it. Please be this. And then we can disconnect it when the player leaves the doorway. But also we'll have to do the disconnect when we enter the door as well, right? Door entered here. Now this is not going to know what the body is here, so can we assign it? If we just do like a var player body. And then here we say, if body is player body equals body. Oh, body. And then we can do player body dot interact. Player body dot interact there. Player body dot interact disconnect. Should be fine, yeah. And then how do we clear? Set it to null maybe? Equals null. And that clears it. Might not need to do all of that kind of stuff, but maybe. Let's see what happens. See what we've got wrong, what mistakes we're going to get. Turn that down a little bit. Right, so we want our door, player in doorway. Non-existent function disconnect in base signal. I thought that's how you disconnected the signal. Oh, it's double N. Is that all? Well, I hope it's a typo. Let's reload. Oh wait, that's going to be the same. Let's just double check that that comes up in the autocomplete. No? Why is it not coming up? Let's stop play. Why is it not auto-completing? I mean, the fact that that's turned blue now, rather than when it wasn't typed correctly, it was green, I thought. No, It's only because I've got the brackets. Ignore that. Let's just have another look about connecting and disconnecting.
Input function. And disconnecting is just as easy. Disconnect. We also pass parameters through signals.
Okay. It's just as easy disconnect, right? Let's see how that works. I'm not too bothered about the leading underscores and stuff like that. So, player left or right, good, okay. So now if we press up, nothing. Interact, nothing. Are they linked through? Okay. You can take that off now. Right, so input manager. Let's just see, print, debug, interact, input. And then this is up input. And then in the player, wait, we're not emitting, that's why. No, we are emitting here. Let's do print debug. Interact door and see what happens with that. Okay, so it does go through to that. So as long as current state is not locked, which current state does not start as anything, right? That's why. So in our game scene, we go to our door, go to the inspector. Current state is locked. Let's do something like this, plus current state. Current state. Plus to a string. We'll do the same with the secondary interact. Secondary door, current state, we'll save. Interact door 0, what 0? 0 is locked. So then if we press up input, isn't linked through. Okay, up input manager. Why is this not emitting? Secondary interact.emit. I feel like I'm close here. Because I'm not connecting to the interact or the secondary interact, that's why. So secondary interact dot connect to secondary interact. And then disconnect. And here, disconnect. Okay, so the door is locked. Now it's unlocked. Now I can open it. And then enter. And that's it. That would be like a scene change. Okay, so that's kind of working. Can I reload? What's reload? Just F5 again. Yeah. Oh, I've added extra A's there. Interact. Okay, so now when I go to the door, I press interact, nothing happens because the door is locked. Then I press up because I've got the key that unlocks it, and then I can open and close it. If I press up when it's closed, it's now locked and now I can't open it. I can't do anything to it. And I can leave it and come back to it, and the state should still be there. So I can't unlock it. If I unlock it, leave it, come back, and try and open it, it opens. If I leave it, come back, close it, lock it, leave it, come back, try and open it, nothing happens, unlock it, open, close. Okay. That looks like that system's all working. And then if I press up to enter it, then that should do a scene change. Or something that basically enters the door. Okay, that's all making a lot more sense to me now. So I think the next thing to do is look up a tutorial of how other people would do this, because I feel like this is a very convoluted way of how to handle this interaction. I don't think it's the best option I could do. But that is a good pause point. I think I'll do another little stretch break and need a little coffee to wake up properly. Refocus. I feel like a lot of this would be stuff that would be taken off into interaction components. It would have an interact and a secondary interact separated. So if we look back at this idea, and where we're looking here about the different components, So using composition, we can do this kind of thing. But instead we could have an interact component and a secondary interact, maybe. Yeah, that could be cool. Okay. Let's do a little break then. And I'll be back in a sec. Let's go to the... I think we'll do the holding screen. Be right back. That. Alright, back in a few minutes. Right. Let's have a little look. So that's got the door working. I kind of want to do some different states on the door. Some different animation options to show if it's locked. So can I... Let's open up a sprite. And we'll have a look at what we can do with that. Or maybe actually, can we do like an overlay? Oh, go away, Steam. So I wonder if there's like a... what they're called, not filters. But like a shade kind of thing. So what would that be? It would be Godot. Change color of sprite. How do I tint the color of the sprite? Here we go. Let's see if that works, because that would be quite an interesting way of doing it, but also Godot shaders. Yeah, we want Godot 4. Introduction to shaders, so on. Let's have a quick read through of this, because I think rather than editing the sprites to have different colors, so for example, we've got our door here. And what I could do is to show like, this is locked with the red key card. We have the door handle be like red to start with. Wait, was that a lighter color or darker? These two dark. And then the rest light. Oh. So I could do something like that. So it shows it's like a red lock. But rather than that, it'd be good if I can just target the handle with a shader. Shader is a special kind of program that runs on the GPU. It's used to shade 3D scenes, but now do much more. Modern rendering engines like Godot draw everything with shaders. Graphics cards can run thousands of instructions per hour. Because of the parallel nature, though, shaders don't process information the way a typical program does. Cannot store data between frames. As a result, when working with shaders, you need to code it differently from other programming languages. Fragment color equals some color. Okay. I think I'm going to have to look for a Godot shader tutorial to get a good understanding of this. Okay, this is something to look into. This is a bigger topic than I can just jump into now. But yeah, what we can maybe do is have locked states here. So let's undo this. And just for the reference here, oh, not that. Let's add in a couple more frames. So yeah, let's do this as our red locked door. This is not going to be an efficient way of doing this. We'll do a green door and like a yellow door, let's say. Let's go this one. Maybe actually we'll do a blue one as well. It's not especially colorblind friendly, is it? Is there anything else we can do on like patterns? Actually, yeah, if we did like a colorblind version, we could have a little symbol underneath with a different shape. That would be easier. So that would be something to consider. So then if we export this sprite sheet. Like how we got it here? We got it as a door like this. And then if we go into Godot, I think rather than this, the animated sprite 2D is a lot easier to use. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that 8? And then in our script, what have we got? We've got play, animation player, play open. So in our animation player here, so that's now wrong because it's doing the wrong frames. So we click on this. And do this as 4, 5, 6, and 7. Or does it go to 8 maybe? No, 7's the fully open. Okay, so that animation still works for the open and close. But in our script, can we say... so rather than locked, maybe here we have another enum, which is lock, and that's going to be red, yellow, blue, green, and none. What order did we do in? We did them yellow, green, red, blue. Yellow, green, red, and then blue. And then we can do here at export var lock type state lock and default it to none. Oh, none is not. So lock.none. Okay. And then really what we want is ready. Function ready. If lock type is not equal to lock.none, then we need to access the sprite. So we drag this in, we hold control, and then we say sprite 2D. Oh no, then we need to match lock type and we say if it's type lock dot yellow, Sprite 2D dot frame 1, no 0. Is this going to work at all? Actually, it doesn't matter what color the lock type is. I think we just do sprite 2D dot frame lock type. Even if it's lock none, I think. I think we just do that regardless. Because if I'm right in thinking, frame has name frame called as a function but is an int. So can I pass this as an int? Oh, wait, frame equals lock type. Is that how it works? We'll have to see. So then in our test scene, set our door type to green. Save that, go to this. Did that work? Green, blue. Let's try green and run it. Is the door with a green lock? Yeah, okay. And then if we change it to red, does it have to reload or will it change it? No, I have to reload it. Cool, okay. We can get rid of this now. Do we care about player detected anywhere? No, we're not doing that anymore. So let's tidy this up a little bit. Get rid of that. Get rid of that. Okay, I quite like how this is turning out at the moment. So then we say here, if lock type is not equal to, no, is equal to lock.none, then our state, current state even, equals states dot closed. Can't find none on lock.none. There's none there though. Oh, because it's capitalized. Else current state is equal to state dot lock. So that's fine for setting the state, unless we wanted just to override though. That's the other question. Because let's say we want to have some doors already open. we'd want to set the state, but then this ready function would set it to closed. So if it's not locked, sorry, if there's not no lock, then we set it to locked. Otherwise we leave it as is. That's fine. So the goal of the player is, yes, it will be. At the moment I'm kind of just playing around with script. And seeing what happens and what doesn't. So this game was going to be for a game jam, but I ran out of time for it. And the idea was to find like different items in the environment and change the environment to get out of the setting. So yeah, it would be kind of escape. It's kind of like I guess a bit of puzzle platform elements, but more leaning on the puzzle side of things. But yeah, because I didn't actually have time to do the jam, I ended up just coming back to this and doing some tutorials around Godot. And now I've got a bit of a better idea. I'm just seeing how signals kind of interact in Godot. So I'm using the door more as an example of how scripts will work, how the codes work. But I think I like this idea. So then if we have a couple of doors, let's duplicate this. And can we move the whole door? So let's have a door over here. A little bit further down. Yep. And then this door, let's set up like here. And let's say this is a green lock door. But if I accidentally set it to opened, that should get overridden, I think. Also, yeah, welcome in Hikital. Is that right? Hopefully that's right. And then in door 3, let's just say this is no lock and it starts closed. Actually, it starts opened. Let's see what happens to that. So hopefully this door is going to be open. This door is going to be green and locked, even though the state here is showing open. And then this one should be red and locked. So let's see if those all work as expected. So opened doesn't work. Oh, it was opened state. Oh, because in the ready function I need to set the correct sprite for it to be opened. Okay, that's fine. This is green and locked. That's correct. So press up to unlock it, and then we can open and close it, and then we can relock it. That's fine. And then this is red and locked. Unlocked, locked. Interaction does nothing. Cool. Okay. So yeah, I think what I want to do is have that here. So if we lock it, so when we lock the door, we just set it to the lock type. And here on ready, we want if current state is equal to state.opened, then we set our frame to whatever the value we want it to be. Open door. I mean, I need to look at this better, but in our door components, our animation player, no, in us, it was 7, wasn't it? Value 7. It's not the best way to do it, but let's just put a comment here for the moment, which is opened door state. And then also when we unlock it, we want to change the color, not to lock type, to lock dot none. So let's see what happens with that. I'm hoping that the first door is going to be open. Right, okay, that's good. So now does it shut when I... Yeah, that's good. And I can lock it, but there's no colour for that one, that's fine. So this one, I can't open it when I try and interact with it. If I unlock it, the colour goes off of it. And if I lock it again, the colour goes back onto it. Cool, that works. And then does this go back to red is the only thing. I can't open it, that's good. If I unlock it, and if I lock it again, it goes back to red. Nice. Okay. So although this isn't doing much, it's giving me a good idea of like how different interactions can work. So here, rather than doing the toggle lock though, I can just do a test. If lock type is not equal to lock.none, then we can toggle it. Yeah, it's a sliding door. It needs a little bit of audio and that kind of stuff to factor in. So now we shouldn't be able to lock this door. Yeah, so the user input is noted, but it doesn't actually lock. If we press up, we can always open it. Cool, okay. So then what? I think that's all I'd need for a door. It's quite a lot of functionality for the doors, but I guess the other thing I could do is like have a damage states and all that kind of stuff. So let's say there's a monster chasing the player down. There might be like a certain amount of damage that the door can take. And then you could show that with like cracks on the glass as it gets broken in. But that's more scope than what I think I want for this little test. This isn't going to be a full game. This is just to help me understand how Godot works. But yeah, I'm quite happy with how that's turned out. Okay, so let's clarify how this is working though. So in our door, when we have the player, when the player collides with the door, we are connecting to the interact signal that comes from the player and telling it to run our interact script, which for the door does the toggle open and close. Yeah, that's fine. So then the player itself isn't actually handling any interactions. The player is just handling the movement. And these are actually used elsewhere. Maybe we don't actually need these on the player. I know, but we're detecting the interact from the player based on the collisions. Yeah, I'm kind of happy with how that setup works. So then the same thing here can apply. So rather than looking at the input event itself, let's see if we do the same kind of thing. So we had var player body, which we've already got. Oh, this is all such messy code. I don't think I want. You just found out that your sprite can be changed on the editor when you change the value of an export by using tool. Oh, that's dangerous. So in sprite can be changed on the editor. I don't know what tool does. What's tool? Oh, thank you. Oh, perfect. What is tool? Tool is a powerful line of code that when added to the top of the script makes it execute in the editor. You can also decide which part of the scripts execute in the editor, which in game and which in both. Be extremely cautious when manipulating the scene tree. Oh, okay. You can use it for doing many things, but most useful in level design for visually representing things that are hard to predict ourselves. You have a cannon that shoots cannonballs affected by the physics. You can draw the cannonball's trajectory in the level editor, making level design a lot easier. Okay. Player doesn't use the sprite but draws itself using code. You can make that drawing code execute in the editor to see your player. Engine is editor hint. Okay. Oh, well, this is powerful stuff. This is dangerous. But I can see, yeah, very useful. I guess most like add-ons and stuff like that use this functionality then. That's cool. Any other GDScript that your tool script uses must also be a tool. Any GDScript in that tool used by the editor will act like an empty file. Okay, right. Wow, this is so powerful. This will be so easy. Well, this kind of stuff for level design, especially like platforming and stuff like that. Set method of your tool not be called. Okay, yeah, this is another rabbit hole that I'm not going to get it into just yet, but we'll keep that open. So shall we see? Yeah, I feel like there's a lot of potential difficulties with that, but I could see so many really useful scenarios for that. Right, so the void return I don't think is necessary to include in a lot of this. Just adds a bit of bloat. Do we want to reassess what this does? Our player script. Or should we have a look at scale machine? I'm not sure yet. I think I need to have a think about what I want to do properly with this game idea next. Because I could really plan out how the game's going to work, or do I just move on into an actual game that I want to make? Because this will be an example one. Where's our scale machine? Did I do it on this? Yeah, okay. So really the pipeworks and all that kind of stuff, electrics, could be on a tile map rather than It shouldn't be built into the sprite like we've got here. Could design out the machine. Let's start making some design ideas. So, what do we need to add? We need to do pixel art for character. And that's going to be so idle. Let's do character idle. Character interact. And character run at the moment. We want the scale machine. Do we want an idle animation or just a frame? Probably off, idle, active. Let's do it like that actually. Idle, interact, and run. Let's get rid of these. And then we probably need a tile map of floor. Just like environment. Tile map for sprites or signage. Maybe just for signage. And lighting maybe. What other things are we going to need in the environment? Maybe like pipework and cables. So does this keep all of the labels, I wonder? Not the ones I want. So we want pixel art. We want a code label. Let's just do a whole setup here. And maybe like a design. And then sound effects. Let's just do audio. We'll lump them together. Okay, so these are all pixel art. Are they on certain numbers or not? No. Four? That's on 5, okay. Door. Lock. Unlock. Open. Close. Let's just do that for the moment. And that we want our audio for. Right, this way, like that. Scale machine. Idle active. It's going to be audio. Player. Interact and run. Interact. And run audios. Let's call it player above. Get rid of this. And then maybe some enemies and all that kind of stuff. They can come in later though, that's fine. Ambience. Still don't know what I want to do with this game though. Maybe next stream we'll do a proper like planning for how the scenes interact and all that kind of stuff. Like a basic storyline or something like that. I think that's what I'm going to do. I think I might wrap up there though. It's kind of a good stopping point, otherwise I'm just going to keep on trucking along. Yeah, let's leave it at that. Thank you to everyone who's been chilling out with us. Anyone who's been lurking and chatting. I think maybe next stream tomorrow. I think I could do, yeah, I can do a stream tomorrow. In which case we'll come back to this and hopefully have a bit more of a plan. I'll probably do a bit of work off stream just to come up with like the game idea, because that's not necessarily something that's that interesting on stream. And then we'll start implementing a bit more of that, build up a level or a couple of levels and see how it goes. Thanks for hanging out. Yeah, have a good evening for you too. Thank you. I hope to see you soon. And yeah, I'll be on tomorrow. So yeah, have a good evening everyone and catch you all tomorrow. Cheers, bye.